Good morning, everybody. Just giving it a few minutes for a few more people to join. We'll get started probably in 2 or 3 minutes' time. Good morning, everybody, and welcome to another GoodWe webinar from the SSA region. My name is Jason. I will be doing the presentation today based on our residential product solution. We'll go into a bit of detail on the ES Uniq series, as well as one of its battery partners or pairings, the Lynx G3 5 kilowatt hour battery. So over the next few weeks or coming months, we will be hosting webinars quite often, sort of every second week or once a month. And we'll be going over a few of our different products and battery pairings that we've got for our regions, and then go into some of our grid-tied inverters, as well as some of our other solutions. We'll also be looking at some of our other applications like our GoodWe Designer tool, as well as the SEMS app that we did in our previous webinar. And we'll be doing this just to enlighten everybody and give you guys some new updated information on all our products and get you guys all in the loop with what's happening with GoodWe today and obviously what's happening with GoodWe for the year. So if we have a look at our product portfolio, you'll see we've got quite a broad spectrum of products, from our residential inverters, from a 700 watt microgrid inverter all the way up to a 30 kilowatt inverter, our CNI grid type inverters, normal 1100 watt DC inverters, and then our utility scale inverters as well, from 225 to 350 kilowatts. All of that gets monitored through our smart energy management system, and that's what obviously allows us to have full control for either commissioning on site to monitoring remotely for the end user, for the distributor, for the installer. Everybody would use that same application for everything. If we look on the right-hand side of that graph, we'll see of the picture, you'll see we've got our energy storage inverters. That's from 3 kilowatts all the way up to 100 kilowatts. And those are the ones that we'll focus on today. On the smaller side of things, the residential products that we've got, and then our lithium battery section as well. So our GoodWe residential product portfolio is quite large, extremely comprehensive, with an offering for pretty much whatever you may need, from microgrid inverters all the way up to three-phase low voltage inverters, high discharge rated batteries, DC-DC HV batteries. We have it all. So today we are going to discuss and go over our ES Uniq, which is the third generation of our ES inverters, ES standing for energy storage single phase. And then we'll have a look at one of its battery pairings, which is the Lynx AG3 battery. Please feel free to ask any questions in the Q&A section. We will go through all those questions and that before we close off with the webinar for the day. So this is the ES Uniq range or ES Uniq series inverter. Again, like I mentioned, ES is energy storage single phase, and then Uniq is the third generation of this inverter that we have. This inverter came into South Africa for the first time in 2014, or into the SA region for the first time in 2014, with the first installations being done in the beginning of 2015. That was our ESG1, our first generation of this inverter. And that was, like I mentioned, 12 years ago. So in 12 years, we've improved on the product and obviously made sure that it stays market relevant and has the correct features and functionality for you as either the installer, distributor, homeowner. If we look at some of the key features for the inverter, we'll go through some of those today. One of them being 200% PV oversizing, high input current on our MPPTs, as well as being CT directly connected, meaning that we don't need a physical external smart meter. We use the CT connected directly to the inverter, and we'll get all of our grid references from that. We also have a 3-in-1 dedicated generator connection or dedicated generator port that we can use in 3 different ways, and we'll go through that when we touch on the key features coming up. So I'm part of the Solar Academy team, which is our pre-sales department. They are in charge of all of our data sheets, user manuals, training installation videos, all of the presentations that we do, as well as assisting customers with speccing the systems, with any product documentation or anything like that, as well as making sure that all of our battery partners we remain compatible with. And obviously, we assist very much with the sales team and our R&D team to make sure that the products remain market relevant and that we move up from there. In saying all of this, we have got a YouTube channel called GoodWe Solar Academy, and this is where we present all of our unboxing installation videos, as well as quick tip videos like parallel systems and that kind of thing. So I'm going to play one of the videos that we have, which is on the ES Uniq inverter, and from there we will move on with the rest of the presentation. Just want to make sure that my sound is working.
Welcome to GoodWe Training Series. Today we will take you through the ES Uniq unboxing and installation. ES Uniq series inverters are available in the 3 to 12 kilowatts power range. This video is an example of the ES Uniq 8 kilowatts. Unboxing. Here is the ES Uniq series box. In the box, there is lead-acid battery temperature sensor cable, BMS communication cable, an accessory pack, documents, mounting plate, inverter. Here are the components included in the accessory pack. Introduction of the inverter. Take a look at the appearance of ES Uniq from different views. Length is 560 millimeters, depth is 226 millimeters, and the height is 445 millimeters. Bottom views of the ES Uniq. There are many ports for different functions. Installation of the inverter. Use a marker to mark the screw holes. Drill the holes using an 8 mm diameter percussion drill, ensuring a depth of approximately 80 mm. Use expansion bolts to attach the mounting bracket to the wall. Fix all 4 screws as shown in the video. Then hang the inverter on the mounting plate. Then install the ground wire. Make positive and negative battery cables. Take out the battery protect cover. Thread the cable into the protect cover. Then install the positive and negative terminals of the cables on the inverter separately. Finally, install the protect cover. You need to hear a click to indicate that the fixation is complete. Make positive and negative 4 DC wires. Plug the PV connectors into the DC input terminals. Take off COM cover. GoodWe provide a 10M cable with CT as default. These are the positive and negative poles of the CT cable. Take out the 6-pin communication terminal from the accessory pack. Connect the positive and negative terminals of the CT connection cable to the communication terminals. Unscrew the bottom of the COM cover and remove the waterproof plug. Install the BMS connection cable and the CT connection cable into the COM cover as shown in the video. Plug the BMS communication port into the inverter. Plug the communication terminal into the corresponding port. And put the cover on. Connect the other end of the DC cable and the BMS communication cable to the battery side. CT connected to switchboard or grid. Remove the cover on the AC side of the inverter. Prepare 3-core cable. Take out the AC pinhole terminal from the accessory box. Attach the AC pinhole terminal to the cable. Take out the AC protect cover. Pass the cable through the protect cover first. Then take out the AC unlock tool. Securing the cable to the inverter AC port. Final installation of the protect cover on the inverter. You need to hear a click to indicate that the fixation is complete. The other side of the cable is mounted on the electrical box. Insert Wi-Fi/LAN kit 2.0 module. ES Uniq installation is complete. Turn on the PV DC switch. The inverter will be ready for operation. LCD screen settings. Compared to first generation, the second generation has a LCD screen. We can configure on the screen. After the inverter is started, we can see the operation status on the screen. Click on Settings in the top right corner. We can make system settings. Click Quick Settings. In Safety Code, select the corresponding safety code based on the country or region. In BAT settings, you can select the corresponding battery. In working mode, set the working mode according to actual needs. In PV concession mode, set up functions according to actual needs. In power limit mode, set up functions according to actual needs. You can set up the CT or meter in the meter/CT assisted test. Click Advanced Function. You need to enter the password 1111. You can do battery wake-ups, offline settings, and shadow scanning. In immediate charging, you can set the relevant parameters. In port connection, you can choose between generator connection or load connection. You can view the information in the device information. You can set the time and date as well as the language in the basic settings. Clicking on the icons on the home page also displays the corresponding information. configuration via Solargo. First, open the app. Select the corresponding signal for connecting the inverter with Bluetooth. Enter the password 1111. You will be prompted to change your password after logging in. Reset your login password. Click Settings. Click Quick Settings. Enter the password 1111. Next, we select the battery model. Select the corresponding battery model for connection. Click Start for system self-test. Quick setting is complete. Thank you for watching. For more installation and configuration videos of GoodWe training series, please visit our GoodWe community and stay tuned to our official account.
Okay, so we'll have a look at some of the parameters of the ES Uniq. I won't go through every single line by line of this. All of this information is available on our website. You'll be able to find all of the datasheet information as well as our user manual, as well as our battery compatibility list, and. So if you need any of this information, you're more than welcome to have a look on the goodwe.com website. But for today's training, we will have a look at some of the data information based off of the data sheet and some of the key features and functions of the inverters. So if we look at the battery input data on the data sheet for these inverters, you'll see I've only added in 4 of the inverters out of the 7 or 8 model range. This is just to give you some information or some guideline as to what the features or functions of the inverters are. So if we look at the full range of these inverters, we've got from a 3.6 kilowatt inverter, 5 kilowatt, 6 kilowatt, 8, 10, and 12. So we have got quite a large array of inverters in all the possible power ranges, depending on the sizes that you may require. Going back to the battery input data, maximum continuous discharging current. This is obviously very much dependent on 2 things. 1, the nameplate capacity or the capacity of the inverter, and 2, how strong or how powerful your batteries are, whether or not the battery can discharge at that rate. So on the 12 kilowatt unit, we can discharge at 240 amps. Again, like I mentioned, obviously battery dependent. Then next is the maximum charge and discharge power. So all of the inverters within the ES Uniq range can discharge at 10% higher than its nameplate capacity. So on the 12 kilowatt unit, 13.2 kilowatts. On the 6 kilowatt unit, 6.6 kilowatts. This is a permanent discharge. Again, this is determined by what the battery can or cannot do, or what the BMS allows the battery to do. Next, and quite uniquely to GoodWe, is the maximum input power on our PV string input data, as well as the startup voltages and operating voltages of our MPPT. So I'll go into a little bit more detail. I'll show you another slide shortly on the input power of our inverters from the PV side. But if we're looking at the startup voltage, all of our inverters start up at 58 volts in the ES Uniq range, and all of them have an operating voltage from 60 volts to 550. Where this becomes very beneficial, or where it can become very beneficial, is if we look at it from a sales aspect. So from a sales aspect, if we look at this, we'll see that the inverter starts operating at a much earlier time in the day because the voltage range starts at a lot lower. So 2 things that we can look at this. 1, if they are price conscious and not too worried about the amount of load that they've got during the day, and they don't need to have a massive PV array, what we can do is we can add less panels in. As long as we try and get as close to the nominal input voltage of 360 volts, we can, however, put lesser amounts of panels in, and we can use that to charge our batteries up. Secondly, if the PV starts operating at 60 volts, means that we get an extra PV production time of maybe 10 minutes in the morning, 5 minutes in the morning, and 5 minutes in the afternoon. and that can be quite beneficial. Again, at 60 volts, we're probably not going to be able to run loads. We know we're not going to be able to run loads, but it can start trickle charging the battery at an earlier time. So, I mean, if we're getting an extra 5 minutes of charge in the morning and 10 minutes of charge in the evening, call it 15 minutes over a day, add 15 minutes over a day over 5 years of the inverter's warranty, and see what the proposal would look like. Better yet, add it onto 10 years of the inverter warranty if we add it with a GoodWe battery, and all of a sudden you'll see the additional PV power that we're generating. So again, from an installation point of view, it doesn't make any change to the system. From a sales perspective, it can become a very big benefit to you and to the homeowner because they get that additional production during the morning and the evenings. Yes, not a long time day by day, but over the lifespan of the inverter can be very beneficial. Okay, so like I mentioned, we do have the maximum PV usage of 200% on all of our inverters, so double the PV capacity of the inverter's nameplate. So on 10 kilowatt units, we can use 20 kilowatts of PV on the inverter. On a 12 kilowatt unit, we can use 24 kilowatts of PV. If we look on the left-hand side, this is just a generic inverter where we would have a 10 kilowatt unit with 20 kilowatts of PV put onto the inverter. We'll get 7 kilowatts or 7 kVA running to the utility, running to the loads, and the additional 3 kilowatts would go down to the inverter, to the battery to charge. There's a loss of 10 kilowatts on the system. A lot of manufacturers out there can do a degree of this, 120% or 140%, where we can use an additional 10 kilowatts of what the nameplate is. On our inverter, the GoodWe ES Uniq, we can do 200% PV oversizing. So on a 20 kilowatt system, we can put 10 kilowatts of PV running directly to your batteries if the batteries can charge at that rate, and 10 kilowatts can run directly to your loads. We generally are oversizing your PV systems anyway. On the DC side, we are oversizing for bad weather, inefficiencies in the panels over a long time, non-perfect installation standards where we don't necessarily have a perfect tilt on the roof, or we can't have it facing perfectly true north, or whatever it is. We add into those kind of things by having additional panels put on to try and get us close to what we need in the efficiency space. But on a perfect day in perfect conditions, we've got an abundance of PV with the battery that's not full, loads that are running, and we can't use any of that for anything. That's where this can be very useful. Just some of our grid data. So all of our inverters can operate between 170 and 280 volts, and we can adjust this obviously according to the national grid regulations or the SANS regulations in South Africa. So we have got a South African grid code that we select when we do our installation, and that is on 230% plus and minus 10%. And we make sure that obviously the inverter stays compliant within those standards. The next feature that we've got is on our AC output data or our backup data. So our inverters can constantly output 10% higher than the inverter's nameplate capacity. So again, like I mentioned on the 12 kilowatt unit, 13.2 kilowatts, it will only do this if the battery allows it to. If the battery does not allow it to output that amount, it's not going to try and pull more from the battery or harm the battery in any way. The same as when it comes to our overloading capacity on the inverters, all of them can do 200% for 10 seconds. So on the 12 kilowatt unit, we can run 24 kilowatts of output for 10 seconds before we get an overload. And where this happens or where this comes from is on the DC capacitors that are built into the inverter, not necessarily or not through the batteries itself. So you don't have to worry about batteries being over discharged or overcharged. The inverter will never harm the battery in that way. Next, we'll have a look at the generator information. So our generator port is completely configurable, controllable, and we can set the generator's incoming voltages, incoming frequencies, prohibited working hours, and that kind of thing. And we can also set the generator's maximum capacity size and all of that as well. Next, we'll just have a look at some of the efficiencies and protections that are integrated and optional on the ES Uniq series. Max efficiency of 97.6%, MPPT efficiency of 99.9%. Integrated DC switch is also included, as well as PV reverse polarity protection. So if we do put our PV strings in and we've swapped around positive and negative somehow, the inverter will not directly damage. It will give us an alarm code, not accept the PV, give us an alarm code and tell us that there's something wrong on site, and we can fix it there. Next is some of the general data. So when it comes to residential spaces, generally, where I live specifically at least, I don't have a garage or an outside area or anything like that where I can install my inverter. So having an inverter that's going to be very loud in my house is not something I want. And this is where the smaller units come very much into play. So on the 3, 5, and 6 kilowatt unit, 3.6, 5, and 6 kilowatt unit, we have got the cooling method being natural convection, meaning there is no forced air cooling. There's no smart fans or anything like that on the inverter. It actually just has a large heat sink on the back of it and cools that way. So it's very close to silent. It runs at 30 decibels when in full production. And we use that in our smaller residential spaces where we don't have the physical space or capacity to install these inverters outdoors, even though they are IP66 rated and can be installed outdoors. Not necessarily every application requires that. We can install these inverters indoors. They're relatively close to silent and they don't require any additional cooling. They have got natural convection cooling, meaning it cools from bottom to top. It just ventilates heat through the inverter itself and doesn't use any forced air cooling on the units. When it comes to the larger units, where we've got a lot higher DC-AC conversion, a lot higher amounts of power running through the systems, we do need that additional cooling. So on the 8, 10, and 12 kilowatt units, we've got the smart fan cooling on the systems. However, these smart fans will only turn on when the inverter reaches 60 degrees Celsius, and then will turn themselves off when the internal temperature of the inverter reaches a lower degree, around 50 to 52 degrees Celsius. All of our inverters come standard with a Wi-Fi LAN kit 2.0 communication dongle, and we use those dongles to make sure that we can connect it to the network so we can do remote configuration, remote troubleshooting, and remote monitoring of the plants. So we can do it either via Wi-Fi or LAN, so running a physical cable, and we commission the systems using Bluetooth or the LCD screen built into a unit. We'll have a look at some of these system diagrams. So the first one is the generator. So when it comes to the generator, we have got 3 different ways we can use the physical generator port or dedicated generator port. On the inverter itself, we have got 2 5-amp dry-contact relays. The first relay we use for start-stop functionality on a generator. So if your generator's got a deep-sea controller or any sort of smart controller that allows for start-stop functionality through a contactor or a relay, we can use our dry contact relay to start the generator up when we require it to. And when running it through the generator ports, we can configure the generator to run in our inverter in a few different ways. So we set the rated power of the inverter, the runtime of the inverter, and then we can set things like the prohibited working hours being times when we don't want the generator to run. So if I don't want the generator to run between 2 o'clock in the morning and 5 o'clock in the morning, I'll set the prohibited working times accordingly. And it does not matter what other settings we have set, it will not start the generator during those times. If we don't have a generator that's got a start-stop functionality like that, we need to use a manual generator, which is what we see more often in a residential space. We can start the generator up on our app. We can just tell the inverter that we have started it manually, and it will open the generator port and allow the generator to continue to operate and provide power to our loads. We'll also set things on the generator, in the generator configuration settings, things like start-stop conditional settings, which are when we want the generator to start up or stop based on battery SOC. Start up when my batteries reach 30%, turn off when my batteries reach 60%, for example, or whatever else we would want to configure. Next is the big load mode or secondary AC output. And this is where we use the generator port as an AC output to or secondary AC output. So this is where we would put bigger loads on, or critical loads of less importance, or loads that we only want to run on the backup side of things during certain conditions. So we can have it either as a manual start-stop, and this is where we would use our second contactor or dry contact relay built into the inverter, and we can have everything start-stop dependent on what we want to do. So we can manually turn it on or off. So allow both backup port and generator port to run towards loads all the time. Or we can have it based on certain times of the day, run it during whatever times we want it to. Within the time management mode setting, we also have an intelligent setting, which means that when we are running and it's during the day, we've got our batteries running full, there's enough PV to provide to all of our loads, and that port is off. When there is enough power sufficient, it will open that port up and allow those loads to run. So if you're running like a pool pump or a geyser or something like that, you can always have it connected to that port. And if during the middle of the day you've got obviously no ESCOM power or no utility power, or you've got utility power, we're running through the backup mode, and we've got all of our loads running, you've got enough PV available, batteries are full, and everything else is available, it will open up the gen port and allow you to start charging or running towards your geyser or anything. During an on-grid application, it will see that as a normal load and be able to run it as normal. It's just during off-grid applications, we can set that time either on or off. We can also do it based on battery SOC settings. So when my batteries are at 100%, allow me to discharge up to my backup loads and to my secondary backup loads, so my generator port loads. And when the batteries reach a certain SOC, let's call it 50%, turn off all the loads in the generator on the generator port and allow only my actual backup loads to run. That way you can run, quote unquote, your entire house when the batteries are full, and when it reaches 50% or whatever it is, turn off everything and only run my core essential loads. The third function or third functionality that we've got through the generator port is our microgrid solution. So through the generator port, we can connect an additional grid-tied inverter and use that for additional MPPTs to be able to run and charge your batteries. So during this, when we lose ESCOM power or when we lose power from the utility, we can still power up the grid-tied inverter, create a grid reference or grid source for them, and allow the grid-tied inverter to start up and produce to either the loads or produce towards charging the batteries on the hybrid inverter. The on-grid inverter can work when grid failures happens to support backup loads and charge your batteries. And then this is not directly specific to only GoodWe grid-tied inverters. Any third-party grid-tied on-grid inverter would also be supported. One caveat to that, we just need to note that the grid-tied inverter can only be of the same power capacity as a hybrid inverter or smaller. So if we have a 10 kilowatt hybrid inverter, we can only use as much as a 10 kilowatt grid-tied inverter, no more, no less, or no more, and obviously smaller is fine. Parallel connections. So we've got two different ways we can parallel the system using the GoodWe inverters. One is using a common battery bank, parallel batteries, and then the other we'll look at shortly. So when we parallel the system, the only additional cost hardware from GoodWe that we would need is the physical EasyLink module. So an EasyLink module is a communication module that we use for the GoodWe inverters. And that EasyLink module we would connect into the master inverter, and the slave inverters we connect via a parallel cable or signal communication CAN cable. When we parallel the system, we just need to make sure all the inverters have got the same operating firmware on all of them, and then we can connect them all together, connect them in parallel. We connect to that EasyLink module that automatically creates the master inverter, and all the rest will become slaves. We can connect up to 6 units in parallel. All of them need to be the same capacity. So if it is a 6 kilowatt unit, all of them need to be 6 kilowatt units. If it's a 10, all of them need to be 10s. And we have got a switching time of 4 milliseconds, but it gives us our UPS level switching. So with parallel battery communication, how it works is we'll have one common LV battery bank, connect it to a bus bar, connect all the inverters to that bus bar, and have our communication running from our master battery into the master inverter. A second way that we can do this is using non-parallel batteries, and this is when we have got a site that is maybe a year or two old and they need to increase their battery capacity, but we can't necessarily just add new batteries onto old batteries because of the SOC deficits that we'll have, or SOH deficits we'll have. We can add a second inverter and different batteries onto that inverter. So on battery inverter number 1, we could have the GoodWe Lynx AG3 batteries, and on inverter number 2, we can connect BYD batteries, inverter number 3, Parlantech batteries. The caveat to that is we need to make sure that the battery capacities are the same. So if we've got 10 kilowatt hours on battery inverter 1, we need to put 10 kilowatts on number 2 and 10 kilowatts on number 3. This is not the most ideal situation as the installer or end user, as one of the inverters may work harder than the other because the battery is obviously older, and we might not get the full output capacity. If it's 15 kilowatts of inverters, you might get a little bit less because of the batteries being older compared to the other two. This is a way that we can save some money for the end user if they need to increase, rather than having to get rid of the entire inverter system and having to install a completely new one, or getting rid of their batteries that are maybe a year old because they no longer have stock of those batteries or whatever it is. So this is a solution we can provide, but the recommendation will always be to please try and use the LV common battery bank solution that we've got here. When it comes to battery compatibility, we've got 2 different ways that we do our battery compatibility. And we have got a list A battery type and a list C battery type. List A battery type is our international compatible battery list. It's available on our website at goodwe.com. And this is where we have taken our inverter, handed it over to a battery manufacturer. The battery manufacturer has handed one of their batteries over to us at GoodWe, and both R&D teams perfectly cross-match the protocol onto each one. When we do the configuration of the system, we then have a full perfect match between battery and inverter. So for example, the Dynas DL 5.0C battery, we gave Dynas an inverter, Dynas gave us a battery, and their protocol, we gave them ours, and we made sure we matched protocol line by line. When doing that, so we have international compatibility, then anywhere in the world, we'll be able to use this Dynas battery. The second way we do battery compatibility is with our type C or local compatibility. And this is where we have a default protocol on GoodWe side. We have an LV default protocol. And what that means is when a battery manufacturer from a local area wants to become compatible with the inverter, we will send them an inverter and our default protocol, and they will cross-match their battery's firmware or battery protocol to match our inverter. So when we configure the system, you will not necessarily see that battery's name. You will connect to our default protocol. This list is available through our distributing partners or through us directly at GoodWe. You can get in contact with us and I'll be able to share it with you, or get in contact with our service team and they'll be able to share it with you as well. Some of the local battery brands that are compatible are brands like Solar MD, Lithium Battery South Africa, Revolve, BSL being one of the battery partners from one of our distributing partners that we use quite a lot as well. When it comes to the warranty side of things with all these batteries, it does not make a difference as to which battery you are using when it comes to warranty on the inverter, provided the battery is part of a compatible battery list. So whether it is a GoodWe battery, a list A battery, or a list C battery, the warranty will still be held on the inverters itself. One of the sales benefits on our batteries or battery partners with ourselves is the fact that we can now upgrade the warranty from 5 years to 10 years when we use our batteries with our inverters. So if you purchase a GoodWe inverter and within the first year of having that inverter, purchase a GoodWe batteries, we will upgrade the warranty from 5 years of the inverter to 10 years on the inverter. So that is a complete ES Uniq battery, ES Uniq series, where we've got the two different models, the ES Uniq 3 to 6 kilowatt unit, which is a 3.65 and 6 kilowatt. Those are the ones that are natural convection cooled, no forced air cooling underneath. And then on the right-hand side, the ES Uniq models, the 8, 10, and 12 kilowatt unit, slightly bigger for more performance and more power. We'll have a quick look at one of our battery pairings. So this is the Lynx AG3 battery. We have a 1.5C discharge, 1C charge battery, and it is able to connect up to 30 of them in a cluster. We'll have a look at some of the connections when connecting these batteries together shortly. All of our batteries at GoodWe can be upgraded locally through the inverter, and they can also be upgraded remotely. How often we do firmware upgrades or needing to upgrade on the BMS side is very, very slim. The batteries that GoodWe manufacture are manufactured and programmed or protocol only for GoodWe inverters. So the chances of massive firmware updates or massive firmware changes needing to be done on the inverters are slim to none. If you have a look at the front picture or front of the battery, you'll see there are two communication ports as well as a dry contact port. The dry contact port we can use for like an e-stop. The two communication ports are completely interchangeable. So if we connect these batteries together to one of our inverters, there isn't a direct requirement for the battery to be connected from the BMS port on the inverter to COM port 2, and then from COM port 1 on the battery to COM port 2 on the other battery, and then COM 1 to COM 1 and COM 2 to COM 2. They're completely universal. So long as we terminate the communication on the end of the chain of batteries, the communication will work. You'll also note there's no dip switch setting on the battery itself. When we turn the batteries on, the battery that is connected to the inverter becomes the master. The rest of the batteries automatically slave themselves. We can black start with the battery as well. We press and hold the on-off button for 2 seconds and then release once the battery's been started. It will black start the inverter. For the distributors, 1 year maintenance free, meaning from time of manufacture. We do not need to run a cycle on this battery for the first year. Once we reach close to that 1 year's mark, we will need to run a cycle on these batteries just to prevent these cells from deteriorating. Just look at some of the parameters of the battery. So this is our Lynx AG3 5 kilowatt hour battery that has got 100% depth of discharge on the battery itself. Nominal charging at 60 amps, continuous charging at 90 amps, which is 0.9C, maximum discharge of 100 amps, and continuous of 150 amps, so 1.5C, meaning we can discharge 7.2 kilowatts on this battery. So where that can come into play is if we've got a 6 kilowatt inverter, we can connect it to one battery. Obviously not going to be for a long time or long duration of savings or long duration of backup. However, we can do it in this way if they have short backup times that they require before they run the generator or whatever it is, or secondary AC output, or however we want to run this, we can just use one battery and be able to get up to 7.2 kilowatts of discharge. Just to note, the battery is IP20 rated, and we've got 3 different ways that we can connect or mount this battery. So either floor mounted, wall mounted, or standard 19-inch rack mounted. We'll go through the 3 racking or mounting structures shortly. Battery weighs about 44 kgs. This is just some of the electrical connections. So the first one that we'll look at is hand-to-hand connection. So hand-to-hand connection is 160 amp working current. We can connect up to 30 of these batteries together. So this is just connecting the batteries from battery to battery, no buzz bar or anything like that. Negative on the first battery going into the inverter, positive from the last battery going into the inverter, and everything connected in between. Please note right at the end, we have got a terminal resistor connected that terminates the communication between all the batteries, and that's what allows us to connect up to 30 of them together. Please do note that we do then have a power limit of 80 kilowatts, 160 working amps of working current. So we can connect as many batteries as we need to together and have a max of 8 kilowatts output through all of the batteries together. If we do need to increase that output power, we can do so using a buzz bar. So we would use a buzz bar for a few different things. One, makes the installation a lot safer. Two, it makes the cabling a lot easier to deal with, makes it a lot easier for maintenance and control, makes it a lot safer. And we do recommend this with any of our installations. If we're installing more than, say, 2 batteries, we wouldn't recommend doing the hand-to-hand connection, depending on the situation, obviously. But a buzz bar will always be our recommendation. So we've got 2 different buzz bars when it comes to the GoodWe side of things. We've got a BCB22 and BCB32. This is what we use to connect to the ES Uniq series. The difference between the 2 is just the physical size of them. So you'll see this one can connect a maximum of 6 inverters and 6 batteries. The BCB32, 6 inverters and 15 batteries. So this, we can then increase the working power to 36 kilowatts or 720 amps. So even if we're using one inverter and we need to increase the working power on the batteries, we can then use a buzz bar and get more out of the batteries itself. Lastly, yes, we can use third-party connections or third-party buzz bars. Not necessarily have to use a GoodWe buzz bar. Please just do go through the user manual and confirm the cable layout for this when it comes to communication. Otherwise, you'll be limited to the 160 amps and 8 kilowatts. I've seen it a few times. There is a termination that needs to be done on the actual cable itself. So we need to just make sure that we do that. Like I said, I've seen this a few times where we've installed a site, they've used a third-party buzz bar, and we get stuck at 8 kilowatts on a 12 kilowatt inverter, and we're not sure exactly how to get that resolved. So it comes down to battery communication. So just make sure that we have got the terminations done correctly, and we've got the cable comms done correctly on the batteries. You'll see the terminal resistor in this battery pack as well, slightly different to one of the previous ones. Inside the box with the battery, you'll get 2 terminators, terminal resistors. One is white and one is black. Both of them you need to please keep with you just in case, and just make sure to reference the manual as to which one you need. So this one terminates 7 and 8, this one terminates 6 and 8, just terminates the different cables depending on the communication that you're using. Lastly is just the material codes for the batteries itself. So we have 3 different ways that we package the batteries. One being the standard method. Standard method of packaging is the inverter connected with a 2 grab handles on the side, which is for a rack mount. Secondly, we have got the stackable brackets, which is our floor mounted brackets that we provide as well. And lastly, the wall mounted bracket. So these batteries can be manufactured or can be installed either upright or horizontal. So we can install them in a cabinet, we can wall mount them, we can floor mount them, and there is a decorative cover that goes over the top of them. It is an RP20 rated battery, so it does need to be installed indoors. Being indoors in a household, if you do want to make it look slightly more aesthetically pleasing, we can obviously add in that top decorative cover just to close off all the terminations, make it seem a bit neater, and make the installation a lot nicer and safer for you and for obviously the homeowners. Thank you very much for all the attendees that joined. I'm going to just go through the Q&A section quickly and just check if there are any questions and just make sure. Okay, there was one question on how many ES Uniq 6 kilowatt inverters can we parallel. Let me just go back to that slide quickly. So when it comes to paralleling our inverters, we can parallel up to 6 units. So on the six, regardless of the size of the inverter, so from 3.6 kilowatts all the way up to 12 kilowatts, we can parallel 6 units together, 4 millisecond changeover time. And the only additional purchase that we need when paralleling the system is the EasyLink module. You'll see there is a smart meter that needs to be installed as well. We have got external smart meters that can be installed. The only time we need to install an external smart meter is when the inverter is installed more than 10 meters away from where we are going to clamp on the CT. Included in the box with the inverter is a 10-meter long RS485 cable with CT connected. Anytime we need to extend past that, we will connect a external smart meter. Okay, thank you very much to everybody that joined. Please do look out for any of our future webinars or trainings that will be coming up. I'm sure the next one will be coming up very, very soon. Thank you, everybody. Bye.